All right, we're wrapping it up. Which polynomial represents this? Well, it's a fair question. First thing, well, we'll do the whole thing, but I'll do it this way. I would say rectangle. Now you could foil this thing, and I don't know what you'd call it if it's foiled beyond this, but this is the way I would probably do this. -3. You could narrow it down. I mean, I was going to point out the fact that the 4 and the -3 is not going to give you a positive 12, but you're still going to need to look beyond that to look at the other stuff. So, you know, cancel these out if you don't do. B cubed is this times this. This times that, again, this is a 1b. That would be a 1b squared. That times that is a -3b. So you're going to have some like terms that you're going to combine here. There's your 4b squared, and those together are going to give you that, well, there's is. There's is. There it is. There's your 5b squared. And so your answer is really A. If you go through beyond this and you got a 1b, 4b, sorry, 1b times 4. 4b minus 3b is the 1b. I think that's what I was thinking. And then minus 12. So these guys and these guys are going to give you the 5b squared and your plus 1b to go with your b cubed and your -12. But that's all to go beyond what you needed there, just to say the answer is A. Equation and function notation for the relation here. A lot of shuns here, okay? So it's just basically y equals mx plus b, folks. You got a y-intercept of 3, you got a slope of -3. The answer is C, okay? Y-intercept of 3, you should have immediately been able to remove the two y-intercepts that weren't the same, and then, you know, check the slope. The slope, is it down 2 and over 1 or down 3 and over 1? And it's down 3. I'm going to go the long version of this. There's a way you can actually do the change of base formula, which simplifies this process quite a bit. But the only way to get an unknown x out of its location there would be to take the log of both sides. Log of 5 to the x power equals log of 50. The reason for that is because this is equivalent to writing it with this out in front. In other words, x log 5 equals log 50. The point of getting that x out in front is now I simply divide by the log of 5 and divide by the log of 5. And you might say, well, wait a second here. What kind of log are we dealing with? And this one here has a little 10. Well, if you didn't write it down, then it's assumed that it's a 10. And so that's why the answer here is A. You can also approach a problem like this by just saying, okay, well, the change of base formula is to say we're going to take the log of one of these divided by the other, and I just tell them always, regardless of how it's written, it can be written like this, where you're dividing by the log of the base. So log of 50 divided by the log of the base, there you see it just without doing any work. Works the same way if you have log base 5 of 50 like this, equals x. The change of base formula works with this, saying again, just divide by the log of the base. Log of 50 divided by log of 5. The answer would be the same for it in this form or that form. Which, by the way, if you rewrote this, 5 to the power of x equals 50, bada bing. Future reference.